Hey everyone. Okay, so let's talk about what makes this problem, which passes all the tests. How does it actually backtrack? What makes it backtracking? And what do we mean by using backtracking? So we'll go into PythonTutor and we'll drop our code in there, and it'll print getting the output permutations. I'll just go ahead and call it because we can kind of see things building in PythonTutor. Okay, did we get enough steps? Yeah, cool. Okay, so let's look at this. So we're going to call get permutations on 1, 2, and 3. So we'll create our output list. It's not one of our base cases. We're at the top, so it's time to loop over the input list. Okay, so I is 0, so we get 1. And you can see on the output, obviously the first one is 1. So we grab 1, and then we get the rest of the list. And so we create another list, right? And it's just got 2 and 3 in it. Okay, so now we call get permutations on rest of the list. Now, remember that get permutations returns an array of arrays. So what we're iterating over here is each individual permutation. What we should get from 2 and 3 is 2, 3, and 3, 2. So we'll loop over 2, 3, and 3, 2 and append them both to I. So we'll kind of concatenate those two arrays together, 2, 3 plus I, 1, 2, 3, and then 3, 2 plus I, 1, 3, 2. And then you'll get both of the permutations that start with 1. Alright, so we call our p permutations thing, and we're not in one of the base cases because it's 2, does length 2. So then you get the element from the input list, and that element is 2. And then the rest of the list is just 3, so that's 1. So now we hit the base cases next time we call this. So what we're going to do here is, now when we're in this second iteration of get permutations, now we're going to find all the possible permutations that could come after 2 and all the possible permutations that could come after 3. And since there's only one more, then we're hitting this, this one element base case, and we're just going to return 3. 3 is the only thing that you could add to 2, since this is the context we're sort of operating in. So now, if 2 is the element, the only thing that we can return is 3, we'll append to 3 to the output of our second call. Now what we're going to do is go to the next iteration of the loop. So we're backtracking at this point. This is the moment where we are kind of going back. We already generated 1, and in a greedy algorithm, usually you're trying to find one solution. But in a permutations problem, you're trying to find all of the solutions. And a lot of times you have to deal with permutations and determining whether or not they're valid. So a lot of problems will look like this in the permutations problem space, and we'll look at another one in a minute. But this is the most basic version. We're not testing any of these for validity, we're just getting them. So, you know, we're iterating on, and now the element is 3, and so what are all the elements that could come after 3? Well, it's just 2, so we're going to call permutations on that, and it's going to say, okay, great, and the length of our list is 1, so we'll only return 2. And so now, it's 2 and 3, and 3 and 2. Those are the 2 possible permutations of these numbers. And now, all we do is concatenate 1. So that's, once we pop out here, we return output. Now we've popped back out into the call where I was the first element. And we have 2 and 3 and 3 and 2 that have come out of the permutations. And so we're now going to add 1, 3, 2 and 1, 2, 3. So let's see, we've got 1, 2, 3 and 1, 3, 2 here. So you can kind of see how that works. Now in later videos we'll go ahead and talk about the choosing element, because that's when it starts to get really important. And we're using recursion here because it's easier to use recursion here. But in many backtracking problems, recursion is kind of the way to go, because what you need to know is, should I keep going or should I not? So yeah. All right, cool. Thanks.